Hi, I'm Dr. J. Glory, Associate Professor of Physics, Institute of Aeronautical Engineering. Today, we'll continue the problem session, which already discussed of the problems. We are discussing the problems in finding the Miller indices. Okay, so now here the problem: determine the spacing between the planes 100 plane, 110 planes, and 111 planes in a sodium chloride crystal, NaCl crystal, having the lattice constant A is equals to 5.64 angstroms. So determine the spacing between. So spacing means D value. So says spacing between 100 plane, 110 plane, and then 111 plane for a sodium chloride crystal, which is having lattice constant A. So that is in angstroms 5.64. So solution, let's write the given data. So Miller indices for the plane we need to find is 100, 110, 111 plane. So let's write the formula, that is interplanar distance. So interplanar distance, or the spacing between the successive planes. So D is equals to A by the root of h square plus k square plus L square. So for the plane D100, for the plane D100, it is equals to A by root of h square plus k square plus L square. So where here the data also given that lattice constant A is equals to 5.64 angstroms. Okay, so we have substituted as it is, as we are finding the interplanar spacing in angstroms itself, so that D100 is equals to A is 5.64 root of 1 square plus 0 square plus 0 square. So that is equals to 5.64 divided by root of 1 square plus 0 square plus 0 square. So 5.64 divided by root 1. So 5.64 angstroms. For the second plane D110, it is equals to A by, that is 5.64 divided by root of HKL. This is so that 1 square plus 1 square plus 0 square. So it is equals to 5.64 root of 2. So it is equals to 3.988 angstroms. So for the value D11, so D111, so here H is equals to 1, K is equals to 1, L is equals to 1. Okay, so it is equals to 5.64 divided by root of 1 square plus 1 square plus 1 square. It is equals to 5.64 divided by root 3. So 5.64 angstroms divided by root 3 value is 3.256 angstroms. So this is the interplanar spacing between the planes 100, 110 and then 111 in a sodium chloride crystal. The next problem, the distance between 110 planes in body centered cubic structure is 0.203 nanometer. Calculate size of unit cell and then radius of atom. So the distance between 110 plane in BCC is 0.203 nanometers. Then calculate the size of unit cell and then radius of atom. So solution for this is, let's write the given data. Miller indices for the plane 110. So the spacing D is equals to 0.203. So distance between the planes interplanar spacing D is equals to 0.203 nanometers. So we have the formula interplanar spacing D is equals to A by root of H square plus K square plus L square. So from this, A lattice parameter A is equals to D into root of H square plus K square plus L square. So let's substitute the values. D is 0.203 into root of, here in this plane, for the plane 110, H is equals to 1, K is equal to 1, L is equals to 0. So that A is equals to, A is equal to 0.203 nanometers, that is the D value, the root of 1 square plus 1 square plus 0 square. So the A value is 0.203 root 2. So the A value will become 0.287 nanometers. 0.287 nanometers. So radius of atom in BCC. So in BCC, radius of atom R is equals to root of 3A by 4. Root 3A by 4. So substituting R is equals to root 3A by 4. So root 3 into 0.287 divided by 4. Then R value become 0.1242 nanometer. So as we or noted directly in nanometers, we'll get in nanometers. So if we convert into meters, we'll get the value in meters. Okay. So if we multiply with into 10 power minus 9, we will get in meters, or else I'll just write in nanometers itself. So size of unit cell is equals to A cube. Size of unit cell is equals to A cube. So A is 0.287 nanometers. So here A cube. So we'll get the value of 0. A cube, when calculating this, A cube 0.287 whole power 3 will have the value 23.63 into 10 power minus 30 meter cube. Okay. So here the A value become 0.287 nanometers. meters. So if we convert this into meters, 0.287 into 10 power minus 9 meters. So while calculating the size of the unit cell, A cube is equals to 0.287 into 10 power minus 9 whole cube. So the value becomes 23.63 into 10 power minus 30 meter cube. This is the size of the unit cell, and we got the radius of the atom in BCC, or is equals to 0.1242 nanometers. The next problem, a copper has FCC structure. So face centered cubic structure with atomic radius or is equals to 0.1278 nanometers. Calculate the interplanar spacing for the planes 111 and then 321 planes. So a copper has a FCC structure with atomic radius 0.1278 nanometer. Calculate the interplanar spacing for 111 and 321 planes. So here the data is given atomic radius R value. So R is equals to 0.1278 nanometers. This is R value. Relation between R and A for FCC. So R is equals to A by 2 root 2. For FCC, R is equals to A by 2 root 2. So this implies A is equals to 2 root 2 R. So A is equals to 2 root 2 into R. So here then we have the value A is equals to 0.361 nanometers. 0.361 nanometers. Okay, so that is here you can substitute the value. A is equals to 2 root 2 into R is 0.1. A is equals to 2 root 2 into R value is 0.1278. When it is converting into meters into 10 power minus 9 meters. So A is equals to get the value of 3.61 angstroms. So 1 angstrom is equals to 10 power minus 10 meters. Okay, so converting into angstroms, we'll get so it is equals to 0.361 into 10 power minus 10 meters. So that we'll write 3.61 into 10 power excuse me. So the value become 10 power minus 10. So 10 meters. So that 3.61 angstroms. So this is A value. A is equals to 3.61 angstroms. As 1 angstrom is equals to 10 power minus 10 meters. So we need to calculate the interplanar spacing. So D is equals to A by root of H square plus K square plus L square. So the planes D111 is equals to A is 0.361 nanometers. So we'll write in the nanometers itself. So let's substitute 0.361 nanometers divided by root of here in this case H is equals to 1, K is equals to 1, L is equals to 1. Okay, so root of 1 square plus 1 square plus 1 square. So here 0.361 divided by root 3. So this value becomes, this is for D11 plane. It is equals to 0.2086 nanometers. For this, to the second D321 plane, it is equals to A is 0.361 divided by root of 3 square plus 2 square plus 1 square. As H is equals to 3, K is equals to 2, L is equals to 1. So 0.361 by root of 3 square plus 2 square plus 1 square. So it is equals to 0.361 divided by root of 9 plus 4 plus 1. So 0.361 divided by root of 14. So it is equals to 0.0965 nanometers. This is for the interplanar spacing for the plane D321. D321. So next problem. Potassium chloride is a FCC crystal having density of 1980 kilogram per meter cube. So this is the density of the potassium chloride. If its molecular weight is 74.6, then calculate the distance from one atom to the next atom of the same kind, and then distance between the adjacent atoms. Okay, so potassium chloride is a FCC crystal which is having density of 1980 kilogram per meter cube, and its molecular weight is 74.6. Then calculate the distance from one atom to the next atom of the same kind, and then the distance between the adjacent atoms. So solution is, given data is density. So density is 1980 kilogram per meter cube, and the molecular weight is 74.6, and then Avogadro's number Na is equals to 6.023 into 10 power 26 kilo mole inverse. Then in FCC, the number of atoms is 4. In FCC means bodies, in FCC is face-centered cubic crystal. Face-centered cubic crystal. So here, face-centered cubic crystal. So along with the corner atoms, there is atoms. There are atoms at each face. So front face, back face, and right face, left face, top face, and bottom face. So like that. So 3 atoms plus corner atoms. So the corner atoms being 1. So 4. Okay. So all the corner atoms being 1 atom, and then in each face of the cube, 1 atom is shared, so that all 6 will get 6 by 2. So 3. So 3 plus 1, 4. So in FCC, number of atoms is 4. So N is equals to 4. We have A is equals to Nm by rho Na whole power 1 by 3. So it is equals to N is the number of atoms, M is the molecular weight. So number of atoms is 4. Molecular weight is 74.6 divided by the density is 1980 into Avogadro's number 6.023 into 10 power 26 whole power 1 by 3. So this value becomes 6.3 angstroms. So this is the lattice parameter value. And we need to find we got the value of A. So distance between atoms of same kind in KCl, that is potassium chloride, A is equals to 6.3. So 6.3 angstroms. So distance between adjacent atoms is equals to A by 2. So that is equals to 3.15 angstroms. So here the distance between atoms of same kind means that the distance. So the distance between here to here is A. So the atom structure will be like this. So atom will be shaped like this. So like this, each corner the atoms are shaded in a unit cell. So here we need to calculate the distance between the atoms of same kind in potassium chloride is. So distance between the atoms is A. Here also A. Here also A. Here also A. But when taking between adjacent atoms, it is A by 2. Adjacent atom is A by 2. Here to here. Okay, so distance between the adjacent atoms is equals to A by 2. So that 6 A by 2 means 6 by 6.3 divided by 2. So that is equals to 3.15 angstroms. This is distance between adjacent atoms. So it is equals to 3.15 angstroms. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.